Hey everyone, welcome back to Maths Nation. Today we're going to be going through the 2024 May Paper 1 Non-Calculator Higher Tier paper. We'll be going through each and every question step by step to make sure we get full marks. Let's get into it. Question 1 says, here are the first four terms of an arithmetic sequence, 1, 5, 9 and 13. Find an expression in terms of n for the nth term of this sequence. So the first thing that we're going to do is we're going to find the difference between each term. So 1 to 5 is plus 4. 5 to 9 is plus 4, and 9 to 13 is also plus 4. And so our difference, d, is 4. And so for our expression, we can multiply 4 by n. And that forms the first part of the expression. We can now test this on, say, the first term. Let n equal 1. So 4 multiplied by 1 gives us 4. We obviously need to get 1 and not 4, and so we're going to minus 3. And that gives us 1. And so our expression becomes 4n minus 3. Let's test this with the fourth term. So if n equals 4, we have 4 multiplied by 4 minus 3, and that gives us 16 minus 3, and that gives us 13, and that is the value of the fourth term. And so our expression is 4n minus 3. Question 2a is asking us to work out 3 and 4 fifths minus 1 and 2/3. In order to add or subtract fractions, we need to make sure that the denominator is the same. And as we're dealing with proper fractions, we'll have to turn them into improper fractions in order to do so. So 3 and 4 fifths. In order to turn this into an improper fraction, you take the big number in front, 3, multiplied by the denominator 5, add the numerator 4, all over the original denominator, which is 5. That gives us 15 plus 4 over 5, which gives us 19 over 5. If we do the same thing for 1 and 2/3, it becomes 1 multiplied by 3, add 2 over 3, that gives us 3 plus 2 over 3, giving us 5 over 3. Now that we've turned them into improper fractions, we can now go ahead and try and get the same denominator. So we're going to multiply this fraction, top and bottom, by the denominator of the second fraction, so 3. And we'll do the same thing, but with the first fraction, so multiplied by 5. So that then becomes 19 multiplied by 3 over 5 multiplied by 3 minus 5 multiplied by 5 over 5 multiplied by 3. So 19 multiplied by 3 gives us 57, and 5 multiplied by 5 gives us 25. We can now join them together as we've got the same denominator for both, and that is 15. And 57 minus 25 gives us 32 over 15. We can leave our answer like this, but as the question started off with a proper fraction, we're going to change this into a proper fraction. And so we ask ourselves, how many times does 15 go into 32? That's twice, with the remainder of 2. So that's 2 over 15. So our final answer is 2 and 2/15. Part B says Kevin was asked to work out 2 and 1/3 multiplied by 5 over 8. Here is his working out and his answer. Kevin's answer is wrong. What mistake has Kevin made? So let's quickly go through Kevin's working out to see where he's gone wrong. The first thing that he's done is he's converted a proper fraction into an improper fraction. So 2 and 1/3 into 7 over 3. Let's see if he's done that correctly. So just as we've done previously, 2 multiplied by 3 plus the 1 over 3, and that gives us 6 plus 1 over 3, which is 7 over 3. So the first line is correct. The next thing that he's done is he's multiplied the two fractions together. When we multiply fractions together, we multiply the numerators together and the denominators together. So 7 times by 5 over 3 times by 8, that gives us 35 over 24. So the next part of his working out is also correct. The last part is to change this 35 over 24 into a proper fraction again. So again, we ask ourselves, how many times does 24 go into 35? Well, it only goes once, and the remainder is 11. So we should have 1 and 11 over 24. So that's where he's made his mistake. Question 3 says that the diagram shows a plan of a floor. Petra is going to cover the floor with paint. Petra has 3 tins of paint. There are 2.5 litres of paint in each tin. Petra thinks 1 litre of paint will cover 10 meters squared of floor. Assuming Petra is correct, does she have enough paint to cover the floor? You must show all your working. Well, let's figure out exactly how much in total of paint she has. She has 3 tins, each with 2.5 litres, and so that gives us a total of 7.5 litres of paint. The next thing that we need to do is we need to figure out what the total surface area of the plan of the floor is. We can do this in 2 ways. We can either cut this shape here, or we can cut this shape here. For this purpose, let's cut the shape in the first way, and so we'll call this shape A, and we'll call this shape B. So to get the area of A, we need 6 multiplied by this length here, and that length is going to be 8 minus 5, which is 3. So 6 multiplied by 3, and that gives us 18 meters squared. If we do the same thing for the area of B, we need the 10 meters here. That's 10 multiplied by the 5 meters there, and that gives us 50 meters squared. And so the total area is 50 plus 18 to give us 68 meters squared. Now, Petra thinks that 1 litre will cover approximately 10 meters squared of floor. Well, we have 7.5 litres, and so to get from 1 to 7.5, we need to multiply by 7.5. We have to do the same thing to the other side of our ratio. So 10 multiplied by 7.5 means that in theory, we should be able to cover 75 meters squared. And so as 75 is greater than 68, we do have enough to cover the entire floor. Part B says, actually 1 litre of paint will cover 11 meters squared of floor. Does this affect your answer to part A? You must give a reason for your answer. Well, we know that the square meters for the plan is 68 meters squared. Now they're telling us that 1 tin of paint covers 11 meters squared of floor. Well, we know that we've got 7.5 litres. And so to get from 1 to 7.5, we multiplied by 7.5. And we'll do the same thing to the other side of the ratio to understand exactly how much we can cover. So 11 times 7.5 gives us 82.5 meters squared, which is clearly bigger than 68. So no. Question 4 is about Venn diagrams. Part A says, write down the numbers that are in set P complement or P dash. And that basically means all the numbers that are not P or not in this shaded area. So that leaves us with 10, 11, 13, 14, 16, and 17. Part B says, a number is chosen at random from the universal set. Find the probability that this number is in the set P union Q. So union here means and. So we want to find out all the numbers that are in both P and Q. Well, if we look at the highlighted area, that tells us everything that's in P, and then we know that this is everything that's in Q. That is a total of 5 numbers. 1, 2, 3, 4, and 5. So our numerator is going to be 5. It's asked us for a fraction, so we need to know the total number of numbers in this set. There's 6, 7, 8, and 9. So a total of 9 numbers, giving us a fraction of 5 over 9, or a probability of 5 over 9. Question 5 says, Sophie drives a distance of 513 kilometers on a motorway in France. She pays 0.81 euros for every 10 kilometers she drives. Work out an estimate for the total amount that Sophie pays. Well, the question's asking us for an estimate. So what we're going to do is we're going to round 513 down to 500. And we're going to round 0.81 euros to 0.8. Now we know that for every 0.8 roughly euros, she can drive 10 kilometers. So how do we get to 500? Well, how do we go from 10 to 500? We multiply by 50. So that gives us the 500 kilometers. And so we need to do the same thing on the other side, multiply by 50, and 0.8 multiplied by 50 gives us 40. So it will cost us roughly 40 euros to drive the 500 or so kilometers. Part B says, is your answer to part A an underestimate or an overestimate? Give a reason for your answer. Well, as we went down, so 513 is obviously greater than 500 and 0.81 is greater than 0.8. We've gone down in our estimates, and so therefore we have underestimated. Question 6 is about straight lines. We have a straight line L drawn on the grid, and it's asking us to work out the equation of L. The general formula for a straight line is y equals mx plus c, where m is the gradient, and we can work that out by finding the change in y over the change in x. So y2 minus y1 over x2 minus x1. C is just the y-intercept. Where does the line cross the y-axis? Let's start with m. So in order to deal with m, we need to pick two coordinates. I'm going to pick this coordinate here and this coordinate here. So the first coordinate is going to be minus 2, 0, and the second set of coordinates is going to be 0 and 3. We then plug it into our equation for m. So m is equal to the change in y, so y2, 3 minus y1, which is 0, over x2, which is 0, minus x1, which is minus 2. That gives us 3 minus 0 is 3, and 0 minus minus 2 gives us plus 2. So our gradient is 3 over 2. To work out c, we just look at the graph and see where does the line cross the y-axis. Well, clearly it crosses at the point 3. So the value of c is 3. We then plug this into our final equation. That gives us y 3 over 2 x plus 3. Part B says that m is a different straight line with equation y equals 5x. Write down the equation of a straight line parallel to m. So the term parallel here is very, very important. Whenever two lines are parallel, we say that the gradients are exactly the same. And so we just need to figure out any straight line with the same gradient. So the gradient of the original line is 5. So we can just write that again as y equals 5x and put anything there. For example, minus 2. Question 7 says that Kasim has some small jars, some medium jars, and some large jars. He has a total of 400 jars. 3/8 of the 400 jars are empty. For the empty jars, the number of small to medium jars ratio is 3 to 4, and the ratio of the medium jars to large jars is 1 to 2. Work out the percentage of Kasim's jars that are empty small jars. So the first thing that we're going to work out is the total number of empty jars. So that is just 3/8 multiplied by 400, and that gives us 150 jars. Now, if we write out the ratios, we have a ratio of small to medium of 3 to 4, and the ratio of the medium jars to the large jars as 1 to 2. We want to combine these two ratios, but we've got to make sure that the medium jars are the same. So we need to multiply these two by 4. And that gives us small to medium to large of 3 to 4, and the 2 multiplied by 4 giving us 8. Whenever we're dealing with ratios, we always want to know what the total is. So 3 plus 4 plus 8 gives us 15. The question's asking us to work out the total number of empty small jars. Empty small jars. That is 3 over 15 multiplied by 150 empty jars. And that will give us 30 jars. Now the question clearly states they want the percentage, and so 30 over the total number of jars of 400 multiplied by 100 gives us 7.5%. Question 8 says that Len has 8 parcels. The mean weight of the 8 parcels is 2.5 kilograms, and the mean weight of 3 of the parcels is 2 kilograms. Work out the mean weight of the other 5 parcels. Well, to work out mean, we know that we need the sum of the 8 parcels. So sum of 8 parcels over the total number of parcels being 8. And we know that the value is 2.5 kilograms. And so if we rearrange the equation to make the unknown the subject, we have sum of 8 parcels is equal to 2.5 kilograms multiplied by 8, and that gives us a weight of 20 kilograms. If we do the same thing with the other 3, the sum of the 3 parcels over the total number of parcels, in our case 3, gives us a weight of 2 kilograms. And so if we rearrange the equation, we have sum of 3 parcels is 2 kilograms multiplied by the 3, which gives us 6 kilograms. And so to work out the weight of the 5 parcels, all we're going to do is say that the weight of the 5 parcels is 20 minus 6, which is 14 kilograms. And so to work out the mean weight, we have the sum of the weight, which is 14 kilograms, over the number of parcels, in our case 5. So 14 divided by 5, which is 2.8 kilograms. And so the mean weight of the other 5 parcels is 2.8 kilograms. Question 9 says that in a sale, the normal price of a coat is reduced by R%. Given that the sale price is 0.7 multiplied by the normal price, find the value of R. Well, if it's already been reduced and our multiplier is 0.7, well, it's 1 minus 0.7 to figure out exactly how much we've reduced it by. That is 0.3. And in order to turn this into a percentage, we multiply 0.3 by 100, and that is 30%. And so R is 30%. Question 10 is asking us to solve these two simultaneous equations, 5x minus 2y is equal to 23, and 2x minus 3y is equal to 18. The first thing that I want to do is I want to make sure that I can take away one of the equations from the other, and that means that the coefficients of either x or y have to be the same. Let's go with x. So I'm going to multiply this equation by 2, and I'm going to multiply this equation by 5. That leaves me with 10x minus 4y is equal to 46, and 10x minus 15y is equal to 90. Now, if I take these two equations away from each other, 10x minus 10x is 0x, minus 4y minus 15y gives me positive 11y, and 46 minus 90 will give me minus 44. If I then rearrange the equation to make y the subject, take the 11 to the other side, it becomes minus 44 divided by 11, so the y value is minus 4. I then need to just plug this y value into either of the equations to work out the value of x. Let's plug it into the first one. 5x minus 2 multiplied by minus 4 is equal to 23. 5x 2 multiplied by minus 4 is minus 8, and minus 8 becomes positive 8, and that is equal to 23. I then take the 8 to the other side. 5x is equal to 23 minus 8. Therefore, 5x is equal to 15. Taking the 5 to the other side to make x the subject, it's 15 over 5, and therefore the value of x is 3. And those are my two values. Y is minus 4 and x is equal to 3. Question 11 is all about translations. Triangle A is translated by the vector 6 minus 4 to give triangle B. Triangle B is then rotated 90 degrees clockwise about the point 1, 2 to give triangle C. Describe fully the single transformation that maps triangle A onto triangle C. So let's translate triangle A to give triangle B. Looking at the vector, we can see that we move across the x-axis, because that's the number at the top, in a positive direction, and that's to the right, and a negative direction via the y-axis, and that's down. So let's take this point here. If we move to the right 6 units, 1, 2, 3, 4, 5, 6, and then 4 down, 1, 2, 3, 4, our new point is here. If I do that for the other 2 points, my new triangle, or triangle B, ends up looking like this. Perfect. The next thing that we need to do is translate B into C. And we know that we rotate B 90 degrees clockwise about the point 1, 2. So let's find out where the point 1, 2 is. That's about here. And we call this the center of rotation. Now, I'm going to quickly do a sketch here. This is my triangle B. I know that if I rotate 90 degrees, I'm rotating this way. And so my new triangle should look like this. The next thing I'm going to do is I'm going to count exactly how far each point is from my center point. Well, let's take this point again. I'm 3 units away across the x-axis and 2 units from the c-axis. And so I'm going to do the same thing, 3 units, but now down 1, 2, 3, and then 2 across, 1, 2, and so that point becomes here. If I use the same method for both other points, my triangle ends up looking like this. Here and here. So that is triangle C. We finally need to describe the translation from A to C. Well, we can see that we've rotated 90 degrees clockwise. So rotate 90 degrees clockwise. We then need to figure out about which point. Well, it will be this point here, because that's the midpoint for each of these points. And that is -4, 1. About -4 and 1. Question 12 says, here are some graphs. Write down the letter of the graph that could have the equation y equals x squared minus 4. Well, we know that the standard x squared graph looks something like this. Looking at the graphs that we have, clearly it's going to be graph H, because it's this graph that's been moved down the y-axis by -4. So answer is going to be H. Part 2 says y equals negative x cubed. Well, a standard x cubed graph looks something like this. And so the negative will be the opposite, which is going to be graph F. Part 3 says y equals negative 5 over x. Whenever we have a fractional graph, the graph tends to look something like this, where the limits are very close to 0 but never touch 0. We have a negative 5 over x. So looking at the graphs available, it's going to be J. Question 13 is about histograms. The table gives information about the amount of time that each of 150 people were in a shop. On the grid, draw a histogram for this information. Well, to draw a histogram, we need the frequency density. And the formula for frequency density is the frequency divided by the class width. We've been given the frequency, but the class width is just the difference between these two numbers in the time units. So we can say class width is 10, 20, 5, 15, and 10. And therefore the frequency density is just the frequency divided by the class width. So 20 divided by 10 gives us 2. 70 divided by 20 is 3.5. 22 divided by 5 is 4.4. 30 divided by 15 is 2. And 8 divided by 10 is 0.8. Now we just need to plot it. So our y-axis is going to be a frequency density, and our x-axis is going to be our time in units. So this will be 10 minutes. This will be 30 minutes, 35, 50, and 60. Our y-axis is our frequency density, and so we just need to come up with a scale for it. We can say 1, 2, 3, 4, and 5. So between 0 and 10 minutes, we know we have a frequency density of 2. So we're going to draw a histogram like so. Between 10 and 30 minutes, we have 70, and that's 3.5, and that comes up to here. Between 30 and 35 minutes, it's 4.4, so that would be there. Now, during your exam, you just make sure that you're using a ruler to be accurate. Between 35 and 50 is 2. And then between 50 and 60 is 0.8. So here. And that's our histogram drawn. Part B says, work out an estimate for the fraction of these 150 people who are in the shop between 20 minutes and 40 minutes. Well, 20 minutes is here and 40 minutes is here. So we need to figure out how many people that accounts for. So 20 and 40. Between minutes 20 and 30, that's 10 minutes. Then we've got 30 to 35, that's 5 minutes. And then 35 to 40, that's also 5 minutes. So we have the time duration. The frequency density for each of these time durations is 3.5, as we can see here. Then we've got 4.4, as we can see here. And then we have 2, as we can see here. So we're going to multiply these together to get the total frequency. That's 35, that's 22, and 5 times 2 is 10. If we add these together, this tells us the total number of people that were in the shop between minutes 20 and 40, and that is 67. They've asked us for a fraction. We know that the total number of people is 150, and so our fraction is 67 over 150. 14 is asking us to expand and simplify this equation. So we have 3x minus 1, 2x plus 3, and x minus 5. We'll expand out the first two brackets and then we'll deal with the third. So 3x multiplied by 2x gives us 6x squared. 3x multiplied by 3 gives us plus 9x. Minus 1 multiplied by 2x gives us minus 2x. And finally, minus 1 multiplied by 3 gives us minus 3. And then we have x minus 5 as the third bracket. We can clean this up by collecting the like terms. 6x squared, 9x minus 2x gives us 7x and minus 3. And we have x minus 5. We then need to just expand these two brackets out, so we'll do the same thing. 6x squared multiplied by x gives us 6x cubed. 6x squared multiplied by minus 5 gives us minus 30x squared. 7x multiplied by x gives us plus 7x squared. And 7x multiplied by minus 5 gives us minus 35x. And then we've got the minus 3 to deal with. Minus 3 multiplied by x gives us minus 3x. And minus 3 multiplied by minus 5 gives us a positive 15. We then need to just collect the like terms. So 6x cubed, we have a third minus 30x here, a plus 7x that gives us minus 23x squared. And then we have a minus 35x and a minus 3x that gives us a minus 38x and then a plus 15. And that is our equation expanded and simplified. Question 15 says, OAB is a sector of a circle with center O and radius 6 centimeters. The length of the arc AB is 5 pi centimeters. Work out in terms of pi the area of the sector. give your answer in its simplest form. Well, we know that the length of a sector is equal to theta, which is this internal angle here, over 2 pi, multiplied by 2 pi r. We know that the length of the sector is 5 pi. We don't know theta, that's what we're trying to work out. 2 pi is just 2 pi, multiplied by the 2 pi, multiplied by r, which is 6. The 2 pi and the 2 pi cancel out. That leaves us with 5 pi is equal to theta multiplied by 6. And so we want to make theta the subject. We have 5 pi over 6. And so theta becomes 5 pi over 6. The question is asking us to work out the area. The area of a sector is equal to theta over 2 pi multiplied by pi r squared. Theta is 5 pi over 6. Multiply that by the 1 over 2 pi. Multiply that by pi. And multiply that by r squared, which is 6 squared. Well, the 6 at the denominator and 1 of the 6's at the top is going to cancel out. The pi and the is going to cancel out from the 2 pi. And that leaves us with the area of 5 pi multiplied by 6 over 2. That's equal to 30 pi over 2, which is equal to 15 pi. And so the area is 15 pi centimeters squared. Question 16 says there are only n orange sweets and 1 white sweet in a bag. Syra takes at random a sweet from the bag and eats the sweet. She then takes at random another sweet from the bag and eats this sweet. Show that the probability that Syra eats 2 orange sweets is n minus 1 over n plus 1. Well, the total number of sweets is going to be the n orange sweets plus the 1 white sweet. So let's work out the probability. Well, the probability that she takes an orange sweet at the beginning is just n over the total number of sweets, which is n plus 1. But then when she takes the second sweet, we've now lost 1 sweet. So n minus 1. And the total has also gone down by 1. So that's n plus 1 minus 1. We can simplify this. That just becomes n over n plus 1 multiplied by n minus 1 over just n. These two n's will cancel each other out, and that leaves us with n minus 1 over n plus 1. Question 17 is asking us to rationalize the denominator of 1 over root 7. So whenever we're trying to rationalize a surd with a denominator, we multiply the top and bottom by that surd, so root 7 in our case. That will equal root 7 over root 7 multiplied by root 7. The roots will cancel out, and that leaves us with just root 7 over 7. And that is our answer. Part B says, simplify fully root 80 minus root 5. So we're going to factorize root 80 into 8 multiplied by 10. And we can't factorize root 5 any further, so that becomes that. We can write 8 as 4 times 2, and we can write 10 as 2 times 5, minus the root 5. 4 times 2 is 16, and we know that that's a squared number, so we can square root that afterwards. Minus the root 5. Square root of 16 is 4, so 4 root 5 minus root 5, that becomes 3 root 5. And so that is our answer. Question 18 is saying, show that 0.15 recurring plus 0.227 recurring can be written in the form m over 66, where m is an integer. So the first thing that we're going to do is we're going to write out these recurring decimals. So 0.15 recurring can be written as 0.151515 and so on. 0.227 recurring can also be written out as 0.2272727 recurring, etc. So if we add these two decimal places together, we get 0.378787 and so on and so forth. We're going to let x be this answer here. So if we do 10x, we get 3.78787 and so on and so forth. The aim of what we're trying to do here is we're trying to get rid of everything that's recurring. So everything after the decimal place. So 1000x is equal to 378.7878 and so on and so forth. So if we take these two away from each other, we have 1000x minus 10x, which is going to be equal to 378.787 recurring minus 3.7878 recurring. 1000x minus 10x gives us 990x, and 378.78 recurring minus 3.7878, so on and so forth, gives us 375. And so if you rearrange to make x a subject, we get x is equal to 375 over 990. This can be simplified to make 25 over 66, where m is equal to 25. Question 19 says that ABC and DAB are similar isosceles triangles. AB is equal to AC and AD is equal to BD. BC and CD have a ratio of 4 to 21. Find the ratio of A to B and A to D. At first glance, it's quite difficult to see how they are similar triangles, but actually if we draw them out again, this is our small triangle A, B, and C. And actually the larger triangle, if we flip it, gives us D, A, and B. And so we can say that side AB is similar to DA, side AC is similar to DB, and side BC is similar to side AB. And so what we can do now is use these similarities to figure out what the ratio is going to be. So we know that BC is similar to AB, and so the ratio between BC and AB is going to be the same as the ratio between AC and DB. Now, in the question, they've told us that the ratio of BC to CD is 4 to 21. So BC to CD is 4 to 21. And so the total is going to be 4 plus the 21 to give us the 25. And so if we say that BD is X, therefore BC is going to be 4 over 25 multiplied by X, and CD is going to be 21 over 25 multiplied by X. We can now plug in these numbers into this equation here. So BC we know is 4 over 25x. AB, as it says here, is the same as AC, so we'll call that AB, and AC, as we just said, is equal to AB, so we'll leave that as AB, and DB is equal to just X. Now, if we cross multiply, it becomes 4 over 25 x squared, which is equal to AB squared. So all we did was take this AB to this side and take this X to this side. We can then square root both sides, and that gives us 2 over 5x, which is equal to AB. Now the question is asking us to work out the ratio between AB and AD. So we know that AD and BC are the same length because they're isosceles triangles. And we said that BD is x, and therefore we can say that AD is also equal to x. And so the ratio of AB to AD would be 2 over 5x to x. We can cancel x out on each side and multiply both sides by 5, and that will give us an answer of 2 to 5. And that is the ratio of AB to AD. Question 20 tells us that 2 to the power of x is equal to 2 to the power of 9 divided by the cube root of 2, and that 2 to the power of y is equal to the square root of 2 to the power of 5. Given that x plus y is equal to 8, work out the value of n. Let's deal with this first equation here. So it says 2 to the power of x is equal to 2 to the power of n over the cube root of 2. We know that we can write the cube root of 2 as 2 to the power of a third. And so rewriting this equation gives us 2 to the power of x is equal to 2 to the power of n over 2 to the power of a third. Now, using our rules of indices, we know that when you have the same base and you're dividing, you can take the indices away from each other. So we have 2 to the power of x is equal to 2 to the power of n minus 1/3. And again, as the bases are the same, we can say that x is equal to n minus 1/3. Dealing with this second equation here, we have 2 to the power of y is equal to the square root of 2 to the power of 5. Now we know that we can write the square root of 2 as 2 to the power of 1/2. And so rewriting this equation gives us 2 to the power of y is equal to 2 to the power of 1/2 all to the power of 5. Now, using our rules of indices, we know that if we have indices that are outside the bracket, we multiply our indices together. And so we have 2 to the power of y is equal to 2 to the power of 5 multiplied by half, which gives us 2 to the power of 5 over 2. Now, as the bases are the same, we can say that y is equal to 5 over 2. The question tells us that x plus y is equal to 8. We know that x is n minus 1/3, and that y is 5 over 2, and that equals to 8. If we rearrange this equation to make n the subject, we have n is equal to n minus 5 over 2 plus 1/3. Now, to add these together, we need to make sure that the denominator is the same. And so a common denominator would be 6. So to get that, we need to multiply 8 by 6, which is 48. We need to multiply the 5 over 2 by 3, and that gives us 15. And the 1 over 3 by 2, which gives us 2. Simplifying this gives us 48 plus 2, which is 50. 50 minus the 15 gives us 35 over 6. And so n is 35 over 6. Question 21 tells us that a solid cuboid has a volume of 300 centimeters cubed. The cuboid has a total surface area of 370 centimeters squared. The length of the cuboid is 20. The width of the cuboid is greater than the height of the cuboid. Work out the height of the cuboid. You must show all your working. So let's start with the volume. We know that the volume of a cuboid is the length multiplied by the width multiplied by the height. Well, they've told us that the volume is 300 centimeters cubed. We know that the length is 20. We just don't know W or H, so we'll leave it as that. And so rearranging the equation, that becomes 300 over 20 is equal to W multiplied by H. And that becomes 15, which is equal to W over H. We know that the surface area of a cuboid is just 2 multiplied by the length and width, plus 2 multiplied by the width multiplied by the height, plus 2 multiplied by the length and the height. They've told us that the total surface area is 370 centimeters squared, is equal to 2. We know that the length is 20, so that's 20W plus 2WH we know is equal to 15. We've just worked that out, so that's 2 multiplied by 15 plus 2 multiplied by the length and height. Well, the length is 20, so that's 20H. If we expand the brackets, we have 370 is equal to 40W plus 30 plus 40H. We're going to take the 30 to the other side. So that becomes 370 minus 30 is equal to 40W plus 40H. That gives us 340, which is equal to 40W plus 40H. Now we can simplify all of this, and that will give us 17 is equal to 2W plus 2H. Well, if we take this equation and we rearrange to make either W or H, let's say W, we know that W is equal to 15 over H. And so now we can replace this W here. And so we have 17 is equal to 2 multiplied by 15 over H, which is equal to, plus 2H. So 17 is equal to 30 over H plus 2H. Now, if I multiply the entire equation by H, that will give me 17H is equal to 30 plus 2H squared. If I rearrange this equation, I can turn it into a quadratic. That will leave me with 2H squared minus 17H plus 30 is equal to 0. Now, all I need to do is factorize this quadratic equation, and I should get closer to my answer. So to factorize this equation, I'm going to write 2H squared minus 12H minus 5H plus 30 is equal to 0. 2H, open bracket, H minus 6, 5, open bracket, H minus 6 is equal to 0. And so my final factorizing is H minus 6, 2H minus 5 is equal to 0. And therefore, either H has equal to 6 or H has to equal to 2.5. Well, we've been told that the width is greater than the height of the cuboid, and therefore H cannot equal 6. And so if H equals 2.5, W 15 over 2.5, so therefore W is equal to 6. And so the height is 2.5 and the width is 6. Question 22a asks us to sketch the graph of y equals sine x for all values between 0 and 360. Well, the graph of sine x starts at 0, peaks at 90, and then go back to 0 at 180, the trough at 270, and then back to 0 at 360. We need to write the limits on the y-axis. The upper limit is always 1, and the lower limit is minus 1. Part B asks us to solve the equation 2 sine x is equal to minus 1 for all values of 0 between 0 and 360. So let's rearrange this equation. We have 2 sine x is equal to minus 1. Sine x is equal to minus 1 over 2, or minus a half. And so x degrees is equal to the inverse of minus 1/2. And we know that that is equal to minus 30 degrees. We're going to use our cast diagram to figure out what this value is going to be. And we need to know in which quadrants do sine equal negative numbers. So it's going to be in the tangent quadrant here and in the cosine quadrant here. Now, to work out the first one, we're going to start always as we always do here. And it's all the way here. So that's 180 plus the 30. So 180 plus 30, which is equal to 210. That's our first value. And our second value, we can start here, but we know that it's easier to just go backwards. So that's going to be 360 minus 30, which is 330. So these are the answers to our question. The last question in this paper says that C is a circle with center 0, 0. L is a straight line. The circle C and the line L intersect at the points P and Q. The coordinates of P are 5, 10. The x coordinate of Q is -2. L has a positive gradient and crosses the y-axis at the point 0, k. Find the value of k. I always find that drawing these out usually helps. So I have a circle with center 0. And I have a line that crosses this at P and Q. We know the value or the coordinate of P, which is 5, 10, and we only have the x coordinate of Q, which is -2. So we call it -2 and y. As this is a chord, the distance of OP and OQ is just the radius, and that means they are both equal to each other. So we can say that OP is equal to OQ. Now, we can work out the distance of OP. That is just the coordinate squared or square rooted. So we have 5 squared plus 10 squared. That gives us 25 plus 100 all squared. And that gives us a distance of root 125. We know that this is also equal to OQ, so OQ is equal to root 125, and we can use this to work out the y value. So that's going to be equal to the squared root of -2 all squared plus y squared. If I square both sides, I'm left with 125 is equal to -2 squared plus y squared, which is 125 is equal to 4 plus y squared. If I rearrange to make y squared the subject, I have y squared is equal to 125 minus 4, which is equal to 121. And if I square root both sides, I have y is equal to plus or minus 11. Now, it's really important that we have the plus or minus here because we need to figure out the one that gives us a positive gradient. So Q can either be -2 with a positive 11, or it can be -2 with a negative 11. Whichever gives us a positive gradient is the coordinate that we want. To work out the gradient of the line, we're going to use our equation of gradients, which is y2 minus y1 over x2 minus x1. We'll pick any of these. Let's pick this one here, and we have our coordinates for P there. So it will be -11 minus 10 over -2 minus 5. That gives us -21 over -7, and that gives us +3. It's a positive number, which means it's a positive gradient, and so we know that this is the Q value that we want to use. Now that we have the gradient of this line L, we need to work out the equation of the line. The general formula of the equation is y is equal to mx plus c. We know that m is 3, so we can plug that in. That's 3x plus c. Now, for the purpose of this equation, we need to figure out what the value of c is. So let's use the coordinates p. So y is 10 is equal to 3 multiplied by 5 plus c. 10 is equal to 15 plus c, and therefore c is equal to -5. And so our overall equation is y is equal to 3x minus 5. Now we know that it crosses the y-axis at the point 0, k. So that's our x coordinate and that's our y coordinate. So we're just going to replace it. So k is equal to 3 multiplied by 0 minus 5. And so k is equal to minus 5. And that brings us to the end of the paper. I hope that helped. I hope you were able to follow each and every question and understand how we tackled them to make sure that we get full marks. Please make sure that you like, share and subscribe and hit that notification bell. Thanks for watching Maths Nation.